Hi everyone. Uh, hope hope you all can hear me. Please let me know if you're unable to hear me. Thanks for joining us today. Today we have Professor Jessie Lee talking about her work on discourse organization and language pragmatics in social media. So sorry for being a little bit late. There are some blue jeans issues, and now I hand over the floor to Jessie. Hi Jessie, can you hear us?
Hi, Monica. So is this still working?
Yes, but unable to see your slide deck for some reason.
Yeah. I'm
Yeah,
sharing now. I just stopped it.
yeah.
Okay, cool. Share screen,
But
and
I think your camera is not on. Do you mind switching it on? You can't see your
uh,
face.
how about now? Can you see my
Okay,
face?
yeah,
Okay,
yes.
cool.
And
And
uh, the slide deck, can you share the slide deck? Seems,
yes,
yeah,
I'll go there. Okay, can everyone see this? So,
yes, perfect.
cool.
Yeah.
Yeah, first of all, thanks so much for inviting me. It's a great pleasure to give this talk. And I'm sorry for the delay. For some reason, my laptop restarts every time I try to run the Blue Jeans events app, which I didn't run before. I've been using Blue Jeans meetings, and it's a different thing. I restarted my laptop 3 times before trying to join on the browser. So um, anyway, let me get started. So I'm going to talk about discourse comprehension today, both from a kind of understanding how we are currently doing point of view, and also from a human point of view to get a little peek at what are humans thinking when they're trying to do high level comprehension. Okay, so to start off, this was kind of me when I was expecting my child almost 4 years ago now. I was really hoping to feel something like this, where, there's a cutie pie all the time. But then life hit, real life really is something like this. And, I think those who are parents would see themselves in this picture as well. So what did I do? One thing that I thought would be helpful is, whatever thing happened with the baby, then, we don't know what to do being a first-time parent. So we turn to the web and look for advice. We found this website called Baby Center. There are all sorts of discussions on different situations when you're a new parent, and it was super helpful. Here are just a couple of examples of what these issues might be, and all of these things happened, by the way, for real. So this is a website that's visited by more than 50 million people each month. And that was data from, I think, more than a year ago. More generally, this is not the only website that parents go to for advice. So there's this Ask Parents subreddit, where people also turn to. And this is not only for parents also. Kids also ask other parents questions on this subreddit. There is the more general advice Reddit dataset website that it's not just about parenting, of course, it's about anything. There is the legal advice subreddit. You have 1.4 million members on there, and it was just a random point in time, and we have 8,000 people online active on this. And same story with relationship advice. And for this one, we have 4 million members. And additionally, we see even back in 2013, 80% of the Americans search for a health-related topic online. So people are actually very actively seeking advice. So what's the experience of me looking for advice? Well, what I found was a generic search really does not fit the need. So for example, I had this question: do you wake the baby for feeding every few hours when the baby is 2 months? Well, I got nearly I got 90 million results, and scrolling through of them was not helpful because the situation did not fit mine after looking down the search. Look for specific advice is also very difficult. So even if I land in a page on, let's say, Baby Center, and I look through the advice, and this is what I see. I see a diverse set of just things, and then maybe buried in there, some of these scenarios actually apply to mine. And also, none of these advice are the same. So a natural question, as NLP folks, we would ask, okay, maybe we can ask machines, right? So now kind of the GPT and friends are doing so well. Can we actually ask machines these questions? So there's a prior paper that helped us answer this question, yes or no. So from Zeller, this graph is from Zeller et al. From UW, and here is the question. So I have to do a dissection for my high school class, but I'm distressed by dead animals. Last time we dissected an animal in class, I had a panic attack. I asked my teacher for another assignment, but she refused. I don't want to play victim card, but I don't know what to do. Help. Okay, so here is the human advice, and we can see it's very helpful. The advice says, I'd send a short email to the next higher up authority figure, identify ideally a counselor, be forthright. It's the best approach when self-advocating as a student. So now, what does GPT-2 say? Go to your teacher and say, I'm asking you to do a project that requires me to see dead animals. This is a deal breaker. If she doesn't concede, tell your principal about your trauma. Oops, that's really not helpful. Okay, so we're not yet there for machine-generated advice. So what I'm arguing is that we actually need better discourse level understanding. So we have seen on and on that Bird and friends have achieved very impressive performance on various tasks. But the question we want to ask a bit more is, do they really get how people use language pragmatically to express themselves and to actually achieve certain goals in real life? So the task that we are looking at is one that require high-level processing, meaning identifying advice. So this was joint work with Katrin and my graduate student Venkat and a few undergraduate students, and was presented at EMNLP last year. Okay, so maybe we could start asking this question and observing qualitatively, how do people give advice? So here is the question. Is it too late to start a hobby or activity at age 12? Now, here's the reply. You can always pick anything up you think is interesting and giving it a shot. You never know what you're good at until you try things. I don't know if you have a budget or maybe borrow tools, but you can try woodworking. It's fun and frustrating in a good way at the same time. So now, if you ponder this advice text, what you see maybe the first thing is not all of the text here actually constitute advice, meaning the gray text is really not advice. Okay, so what's there and how do people express advice and non-advice? So here, let's consider a second question. Parenting with a history of depression. And here is the advice. I took my meds the whole time. I used the tools I learned in therapy. I talked on Reddit with others to get support and ideas. So never in this whole text did that person say, you should do X, or I suggest that you do X. But rather the person is saying what his or her personal experience were, and kind of try to nudge the person to maybe suggest you might want to do the same in a very implicit manner. So as it happens, we actually don't yet have a good understanding in the existing literature of how do people give advice. So there has been some earlier work on that relied on explicit rules, things like I suggest, I recommend, you should. There has been also a Semival task on suggestion mining. However, this task is a sentence level task where each sentence is considered out of its context. Also, advice is a more concrete type of suggestion. So, for example, depending on the context, the sentence, you should try the food at Italian restaurant may or may not be an advice. Okay, so to help us push this boundary a little further, we asked two research questions. One is, how is advice structured online? And second, how good are computational models at identifying advice? So first question. So to answer the first question, we started with inspection of the data and annotation of the data, as we usually do. So the sources of advice we look for is our need advice. So this is a subreddit. It's a general advice forum. It's very heavily moderated for content quality. And there are also flares that these posts are organized into. So the flares are generally corresponding to topics like education, career, mental health, life decisions, and friendships. There is also another data set that we consider, which is our Ask Parents. This is parents or kids asking questions. It's less moderated, and there is no subtopics or flares. So how do we even get advice in the first place? So the first concern we have is we don't even know that people agree or disagree with each other what actually constitute advice in a lot of text. So the thing that the option that we chose to do is to ask annotators to highlight the text that they think constitute advice and see if we can get some agreement there and get some reasonable aggregation there. So, for example, if we see a question like this, and what we did was to ask 5 annotators on Mechanical Turk to highlight sentences or really chunks of text, not just sentences, that they feel would constitute advice. So what we end up with is something like this heat map where if we have more people identifying a chunk of text as advice, then we have a darker shade of red. For label aggregation, after having this a bit noisy heat map, what we did was to use the DeWitt-Skinny method on the sentence level, and this is an EM algorithm that tries to estimate the probability of a label that by taking into account also annotator quality. So as a result, in the end, the aggregated label will look something like this. So a text is either advice or not. Okay, so to see if people actually have an inherent notion of capturing what is advice, we look at the inter-annotator agreement. We consider whether people agree, whether experts agree with each other, and whether aggregated labels agree with experts. So for the trained experts, we sampled a couple hundred sentences and asked them to annotate, and we do observe moderate annotator agreement. So what's interesting is that the expert adjudicated labels actually agree pretty well with the aggregated labels from Turkers. So from this, we are fairly confident that people do agree with each other on, and they do have an inherent perception of what is and what is not advice. And here is the statistics of the data. We sampled around 680 posts and annotated around 18K sentences, and the data and code is available. So having constructed the data, we are ready to maybe answer some more interesting questions. One is how much advice is there? So we have seen before that not all of the text in a reply is actually advice, and this graph verifies that claim. And in fact, most of the things that people say are not advice in those forums. So we can then dissect this data set into two portions, analyzing what's in the advice and analyzing what do people say if they're not expressing actual advice. So first, how is advice expressed? We see a lot of personal narratives. So I did something like we've seen before. We also see questions and also advice framed in imperatives and also in conditionals. We are more interested in implicit advice. So these are advice that are not easily captured with either syntactic structure or explicit cues that are very lexical. So we analyzed about 13 posts labeled as advice or not advice, and get the sentences from these advice sentences and see whether they contain personal narratives. So we see that around 16% of the time in Ask Parents posts that people express advice as personal narratives. This percentage is much lower for need advice. However, we do see for certain subtopics, people use more personal narratives more often than others. Okay, so now what is in non-advice text? We see that actually people very often express sentiment and express their support. So good luck on your interviews and fingers crossed. People also argumentatively support their advice. So for example, in this black text, this is a strengthening of the argument that is presented in the advice, which is in gray. People also provide background reasoning for the advice. So for example, this text, yes, no one will ever know the big answers to the big questions. This is a foreground and lays kind of the overall reasoning of direction to the advice that follows. Okay, so we have seen so far that advice is mingled with non-advice and it is distinguishable by humans, and that people use very rich linguistic strategies to express the advice. So now what we can test then is how good are computational models at identifying advice. So we frame the advice identification as a binary classification task. And the baseline we run is the SAM-eval baseline, which is rule-based on regular expressions and certain words and phrases. And the models that we look at is a more of a diagnosis model where we just use the simple BERT. We here consider BERT just the sentence itself taken out of the context, the sentence plus the question of the post, and also the sentence plus other sentences in the same reply as context. What we see is, I think, both expected and surprising at the same time. So first of all, if we look at the baseline performance, which is in blue, this is certainly shows it's a very challenging task. If we compare the green bar, which is BERT on the sentence, with the blue baseline, we see that BERT is able to help the performance quite a bit, especially in need advice. However, adding context is not something that could help, at least not in this vanilla architecture. So adding the context, we see that it's giving you the same performance as just the sentence itself, and adding the question actually hurt the performance. So this is a little surprising to us because clearly when people are judging whether something is advice, they consider the context to be significant, but that's not what the model is being, it's not something that the model is capturing. So what is the model capturing then? So if we look at the visualization of BERT's attention heads, what we see is that BERT is able to identify lexical items very well. So for example, in this sentence, I would encourage finding a therapist to add to your support team. The modal verb would is kind of paid attention to quite evidently. So also, in this sentence, I suggest trying a dose of Tylenol. That is the word suggest is also highlighted by the attention. So in a sense, even though we didn't give BERT the explicit lexical cues, BERT is recovering some of them. So what is challenging then to learn? We suspected that BERT is actually not capturing the implicit advice. And a good way to test that is to take a closer look at the personal narratives. So to do that, we approximate personal narratives in the test set by checking the presence of pronouns of me, my, or we. So here is the result. So on the left, we have the lighter orange bar, which shows kind of the F measure of the kind of what we've seen before. On the darker orange bars, we show the F measure of only those that we deem as personal narrative posts. And we see that the performance of the latter is much, much lower than the former, regardless of which subreddit we're looking at. So I guess the takeaways here is that BERT and his friends are getting better than rule-based systems, but not great. They capture lexical cues that are indicative of advice, but they also struggle at higher level processes, meaning implicit advice. So maybe now that we see that BERT is still struggling a bit on the pragmatic tasks, we can get some insights on how humans actually comprehend text via a paradigm that is question generation. And this is a joint work with my graduate student, Wei Jin, and master students, Teyuan and Ian, and also my colleague, Greg. All right, so if we take a step back from all of the buzz that you have heard about question generation in the NLP world, what is the goal of question generation? Or let me rephrase it as, why do people generate questions? Okay, so if we think about that question, questions actually serve to better understand natural language. And it's very organic. You do that all the time. You do that implicitly when you're reading. And the reason you do that is there is something inherently that you're curious, that you're dying to know. So it arises from the perception of a gap in knowledge or understanding. As an example, let's consider the situation that you're reading through an article. Here's some prior context, and that establishes your common ground of the article. And then here's the sentence that you encounter as of now. You have not seen anything that comes after this sentence yet, okay? So when you're reading this sentence, you say, okay, this gritty city of 7.6 million rarely gets respect. It often ranks low in livability surveys and near the top of the hemisphere's ugliest capitals. Okay, you might ask the question, why is the city referred to as gritty? Why does it rarely get respect? What constitutes livability? And what are some other ugly capitals in the top of the hemisphere? Okay. So, generating questions is actually tackled by NLP, and for the goal of, if you're able to ask the right question, then it reflects your ability to understand language, to gather your new information, and to engage with users. But most of the existing question generation work actually rely on existing question answering data sets. And what we see is that these are very different frameworks. So here is a typical a text from a question answering data set. Typically, it's Wikipedia. So this is Wikipedia text. And typically, also, you see a chunk of text that is the answer, and you ask a question about that chunk, and then you find the answers. So in our case, we see that it's actually a very different paradigm as what we are looking at, meaning you actually first see the answer, and then you test the person's comprehension by looking for that answer. Whereas when you're reading along, there are questions that arises inherently in your head that may or may not be answered in the upcoming text. Okay, so the questions that we're tackling is A, what are people pondering as they read through an article? And B, are we able to generate such questions in modern NLP techniques? Okay. So first, we kind of collect the inquisitive data set. So we source text news articles from Wall Street Journal, New Zealand, and the AP, 500 articles from each. And we only consider the first 5 sentences from each article, mostly because of the complexity of the task. And basically, when we ask people to annotate on Mechanical Turk, we give them this kind of interface where each sentence is shown one by one, and they can ask questions by highlighting any span in that sentence. And they could ask a question about that span, and they can ask up to 3 questions for that particular sentence. In order to verify that the questions that we collect is good and to exclude any bad questions, we do a separate task of question validation on Mechanical Turk. And that is, we present the validators with both the question and the text and the context. And we ask them whether this is a valid question, meaning whether the question is linguistically meaningful and well-formed. And second, we ask whether the question is related to the text that people actually highlighted to say this is about the question. And finally, we ask whether the question is already answered in the prior context or in the current sentence. And here, we do not want the questions to be already answered because we want to capture the ones that truly reflect curiosity, and you can't ask a question that you're curious about when you already know the answer. All right. And we see that most of the questions are actually pretty good in quality. We observe only 5% of noise where any of these 3 are checked to be invalid or unrelated, not related, or already answered. So to look at the distributions of questions, first thing we notice is that the questions are very different from what existing QA datasets are. So here is a comparison of the top bigrams of the questions against most popular QA datasets, and some of them are heavily used in question generation work. So we see that in our dataset, we have more why questions than any other, and more like how questions also. And if you look at these, for Squad and Quack, we see more detailed questions. And for News QA, there is actually a specific instruction in their data collection phase where they discourage high-level questions like us. Okay, so then with this data, we may be able to get an idea of what information are the readers seeking. So we manually looked at some of the questions that are gathered. We found that 30% of the questions from our sample of 200 is why or causal questions. 13% of them are definitional questions. And 8% are instantiation questions like these. So if you have a group entity, people are curious about what are other members of this group. There are also other types of questions. We see elaboration questions. So if people want to know the details of an event, they would ask this question. background questions. So if a person is not familiar with the domain of the text, then they would ask for a specific background for more elaboration. And forward-looking questions, so questions that are about what happened next. So, for example, if the dinner was a confirmation that 1989 was the worst year ever, they would ask, did it get worse after this? So one thing you might ask is that, if you pose any text to mechanical Turkers, they might just deign to ask some questions, and how would we know that these questions are actually meaningful? So we accounted for that as well. We incorporated a question validation stage where we ask people, should this question be answered in the rest of the article as an additional question? And this is rated on a scale of 1 to 5. Note that this is not the same as the importance of questions. So, for example, some of the definitional questions are very important for the comprehension of an article. However, you might not expect the article to actually give a definition of a particular term. But in general, if the questions that are asked are genuinely reflects more people, like the underlying curiosity of more than the particular Turker that we're asking, then people would also agree that this is a question that they should be answered in the rest of the article. The good news is that we do see very good salience score on the average of 3.18. And moreover, we see more than 70% of our questions are rated as a salience of 3 or above. Okay, so we see that people are highly inquisitive and engaging while reading, and this is reflected by a large number of high-level questions seeking a wide variety of types of information. So now, are we able to generate such questions using modern NLP techniques? And here we consider 2 questions: A, the role of context into such models, and B, the role of highlighted span, and do we even need to provide such a span to the models? To consider the role of context, we fine-tune a GPT-2 model for question generation. For our full model, we give GPT-2 the context, which is the previous sentence that is before the sentence that the question is raised, the sentence where the question is raised, and the highlighted span. And then with the delimiter, we show what is the question. So we call this full model inquirer. And then to shrink context a little bit, we compare with a model that is span plus sentence. We see here we only give the sentence with the span highlighted, and no previous context before the sentence. We also give the question. And finally, the smallest context window we gave for this test is the span-only model, where we only give the highlighted span. Okay? All right. So here are the results. This is done in human evaluation as the same process as the validation stage of the third questions. On the very left bar, we show human performance. And on the very right bar, we show the performance of our full model inquirer. And in the middle 2 bars, we show the light orange being only the span is considered, and the slightly darker green, darker red shows just the span, not just the span, but also the span plus the sentence itself. And we see that when we add more context, we see more valid questions, and the questions are also more related to the highlighted span. Okay, the question salience also improved when we consider more context. But notice that the percentage of valid questions is way lower than human generated questions. So here's an example of that shows the value of context. So here's the context. Japan health officials found fungicide in imported U.S. apples. It's not a safety issue by any means, said the government spokesman. It's a technical one. The fungicide is also commonly used by farmers in Japan. Several stores in Tokyo were voluntarily recalling the apples because of possible health hazards. However, supermarket chain Daiei Inc. said that company has no plans to remove U.S. apples from its shelves. So here is the question generated by our full model with access to all of the context. The model says, if this is the case, why have no plans to remove them from their shelves? It's kind of wordy, but in a sense, it's a good question. It actually would be something that I also would ask if I were reading this. But if we take out the context, if we only give the span and just the sentence, we see that here's the question. Why would the supermarket chain remove U.S. apples from its shelves? In a sense, it's not really even a good question to be generated. Okay, so now that we know context is important, maybe we can also think about whether the highlighted span is needed. So in Inquirer, our full model, we gave the model the span information, which is annotated by humans. But what if we don't? So we compare with a model that is just the sentence and the context. There is no information on whichever span it is. We hope that GPT-2 will be able to capture that implicitly. We also train a model that is a pipeline model where we inform GPT-2 more explicitly what is the span by predicting the span using the BERT model. So to look at the results, we see that so here the leftmost bar is still human evaluation. Evaluation on the human data. The rightmost bar is still the full model Inquirer. And then the middle two bars on the left, we have sentence plus the context without knowing what the span is. And here, this light darker red, it's the pipeline model where we predict where the span is. And we see that predicting the span actually helps to make the questions a little bit more valid. We see that it's not doing that bad in terms of being actually related to the span. However, more questions are actually being answered, which is not that great. And also, without informing the model of the span, we also get slightly lower salience score. So it seems that GPT-2 is able to generate quality questions most of the time when given the right amount of context, yet it still falls short of human performance. So then when we're on the topic of knowledge gaps, and we have seen that some of these are triggered by our innate curiosity, then one other application that we could look for evidence of human reasoning, of high-level reasoning, is the case of explanation generation in document simplification, where when you're talking to another audience about the same content, you reason the ability for the other person to reason, you would impose some sort of explanation for certain concepts. So this work is with my student Niha, and this is on arXiv. Okay, so what we have seen in document simplification is that it actually involves content addition. So, for example, here is an original text. Results, she said, could help the team better understand ancient Egyptian health and correspondingly modern day health. For instance, some mummies still have arteries in their mummified remains, Miller Thomas said, and sometimes scientists can tell if these arteries have hardened. Now, here is the simplified version. The scans could help the team understand about ancient Egyptians' health. Obviously, this is a simplification of the first sentence. And this is the second sentence in the simplified version. For example, some mummies still have arteries. And obviously, this is a simplification of the second sentence. Now, here's the third sentence in this in the simplified document. An artery is a tube that moves blood through the body. It's not anywhere in the original text. Rather, it's a definition of a term that is being used in the original document that also appeared in the simple document. Now, here's the fourth sentence. The artery could show if the person had been healthy or not. Also, strictly semantically speaking, none of that meaning appeared in the original document explicitly. Rather, it is an explanation or reasoning for the last sentence in the original document. So if we look at the existing literature on simplification, and I know Wei did seminal work in this area, we understand sentence-to-sentence simplification very well. This is typically done with a monolingual machine translation task. However, content addition isn't something that we have studied before. There has been some prior work, but they mostly looked into retrieving and inserting definitions. So with this work, I will briefly summarize the three research questions. Do people elaborate in general using simplification, and why? How do we characterize elaborations, and can we try to generate elaborations? So very briefly, the way we collected the data was we started with sentence-aligned data and found sentences that are not aligned in the simple document. And for those sentences, we ask people to verify whether they are truly added content, whether that's content already existing in the original text. So if we take a look at these elaborations, so for example, the first one is this, and his wife is inspired to get her GED. The GED is equal to a high school diploma. It is for adults who are unable to finish high school. So this orange text is added as content. Here is another example. The National Mall is a stretch of parks and museums in DC. Its nickname is the nation's front lawn. Every year, millions of tourists visit it. And here is another example. Claudia goes to 2 different schools each year. She gets straight A's at one. Her grades are lower than at the other. Switching between schools makes it more difficult to learn. So we see that there is, besides definitions, there's wide variety of content that people do add into the simplification process that includes explanations, clarifications, and analysis, and so on. And the linguistic angle we chose to look into is to see how contextually specific the added elaboration is. So for example, if we consider the first sentence and the elaboration, it is for adults who are unable to finish high school. This has fairly low contextual specificity, meaning that you can actually plug this elaboration into many other situations when you want to mention the GED. Okay, so in a sense, it's not specifically tied to this document. In the second case, this is medium in terms of contextual specificity, because yes, there are many situations that you can insert every year millions of tourists visit the National Mall, but there are also contexts that you would not do so. And finally, for the last one, it is of high contextual specificity, meaning that this sentence is tied within the context very deeply to explain why Claudia, the grade is lower in one school than the other. So we also collected contextual specificity annotation with both expert and crowd workers. And we see that if we look at the distribution of contextual specificity of low, medium, and high, and we see that they are evenly distributed. Okay, so I will skip the experiments and I'll just show the highlights, and you can, if you're curious, you can read the experiments in the paper. So we try to predict contextual specificity. It is a possible task, but it's very challenging. It's, again, one of these tasks that require these high-level reasonings. we also try to incorporate contextual specificity into generation model. In this case, we use GPT-2. And we found that it is helpful in both human and automatic evaluation. And if you're curious again, see our paper. So in conclusion, we see that people organize their text, use a very rich set of discourse strategies, and they comprehend text to attempt to answer high-level questions. So I think machines should be doing the same. We're not there yet, and we need to get there. And that's it. I thank my collaborators and my students. And my student Venkat, Weijin, and Niha are co-contributors to the work that I'm talking about today, and also my collaborators, Katrin and Greg. Thank you. That's it.
Thank you, Jessie. Thank you so much. Very interesting talk, and I really liked the amount of details and the annotation that's going on to capture different things. So,
Thank you.
Like we have a question here from and everyone else, please post your questions in the QA chat as Sofan Pai has a question. Is it possible that sent plus Q model performs worse just because the input sequence is sort of out of distribution compared to BERT pre-training corpus? Also, I'm curious whether you have tried the BERT sum structure to formulate input where there is a separate CLS token for each sentence.
That's a really good question, and this is exactly what we're suspecting. I think the change of voice in like when you incorporate the question, exactly what threw off the model. And yes, we are currently exploring kind of better models and better architectures to do this. And yeah, thank you for the suggestion. For BERT sum, we will try it.
Yes, I think. Yeah, I have one question. So in the first paper, you were talking about like personal narratives. There was some trouble recognizing the personal narratives. Do you have any intuitions as to why? Is it because it lacks lexical cues, or is there something else going on there?
Yeah, so yes, it's definitely because it lacks lexical cues. So we looked at BERT and attention in detail. I know attention is not sometimes not explanation, but we did look into that. We found really the most significant contributor for identification of advice is lexical cues like would, suggest. So these very explicit things. The pronoun I was interestingly also identified as very often as an indicator. Well, I think that BERT actually is getting some notion that if you see a lot of I, then it, sometimes it is advice. However, we found that the use of I is indicative in both ways. So you can use a lot of I when you're making a personal narrative. You can also use a lot of I when you say, I suggest that, I suggest X, right? So, I wouldn't do it, or, it's like all over the place. So it's fairly noisy, that use. So, which is another reason why we actually use the pronouns we or me or us in the kind of examination of personal narratives. So yeah, I think BERT is definitely struggling with a lot of the implicit advice in there, and personal narrative is definitely quite challenging.
Yeah, and I think all the work, the data sets that you showed are really good test beds to understand if the models have are getting the implicit knowledge. So that's interesting. So there is another question from David. Did you do any follow-up on inquisitive question generation to see how well models can fill in the missing details? If so, how does performance on these type of questions compare to ordinary QA data sets?
We are working on this. So we did some preliminary experiments with existing QA data sets. I can tell you they don't work at all. So the key difference is that the questions that you found in inquisitive are very high level. A big chunk of them are actually like if we look at the nature of these questions, sometimes people would agree or people would disagree whether this question is fully answered and whether and where the answer is, if any. So we see a lot of like, so for example, if you consider a causal question, there are several places in the document that may be related, and even that relatedness is a little bit subjective. So I would say, trying to find the missing details is a very challenging task. We are trying to tackle that, but it comes with a bag of different things and existing QA data sets. I don't think it would work.
And I have one more question, like about evaluation for because these were the question generation. There is no. It's very subjective, and there is multiple possible things and multiple possible questions that you can ask. And I saw that you did a human evaluation for it, if I'm not wrong. So I'm curious, like, is there any good automatic evaluation metrics for something like this, or where do they stand for this task?
Sorry, can I repeat your question to make sure I understand?
No, I'm just curious if you maybe I got it wrong, but I saw that for the evaluation of the question generation part, you had mostly human evaluation scores, right?
Yes.
Valid, related. So are there currently any automatic metrics for these kinds of tasks? And did you look into them? How good or bad are they? So I'm just curious about it.
Okay, yeah. So there are, of course, there's always Blue. There are modern versions of Blue, and there are also more recent work on kind of high entropy generation tasks. We did not do any of them because we didn't trust them. And also, I think this is a fairly new task. It's not like other QA tasks where you know where the answer is. So the expected distribution or the space of possible questions isn't that big. But I think in our case, it is fairly high in entropy. So, that's why we resorted to no, we're not going to do any of the machine to kind of confuse people, just rely on the human.
Yeah.
We did verify our human evaluation process by checking the Turker validation with ourselves. We do agree with Turkers almost all the time. So
I think that was what I was going to ask, how did you do the quality control? Because I feel like this is a very high level task, so evaluation is going to be
the evaluation. Yeah, so the questions we ask are fairly concrete during the evaluation stage. So I don't think the evaluation. So I think kind of the subjectivity mostly comes in when people are asking questions, but we actually don't see a lot of variance. When we analyze, during the validation stage, people tend to agree with each other. They don't really agree on the salient score, though, which was why we didn't put it fourth and foremost. We don't think people have their notions, but they're like much more varied than the other attributes that we are evaluating. Which it's expected because there's expected discourse of an entire document is too large, but at the same time we don't feel that it's perhaps a validation of the questions, but it's not something that you can say for sure that people know this is important.
That makes sense. I think we are out of time now, and yeah, thank you so much. Thank you so much, Jessie, for the talk. It was really fun, and thanks everyone for joining us. See you for the next talk. Bye.
Yeah, thank you, everyone. I really appreciate these questions, and yeah, sorry again for the initial technical stuff. All right.
Thank you. Bye.
Bye.